Welcome everyone! My name is Timothy Lee Grant, and today we are going to continue grinding LeetCode. And as I said previously, I first started with depth first search, and I focused on that, focused on it until I could get to the point where, I was kind of reasonable with it. Okay, then I'm going to start shifting my focus from depth first search to a different topic. I'm going to get really good at that topic, and then I'm going to go back to depth first search. So it's kind of that learn and forget kind of methodology, and that's kind of how I'm going to be moving forward in my LeetCode journey. So today we are continuing learning the other topic, the second topic that I'm jumping to from depth first search to heaps now. So yesterday we were able to solve one easy problem with heaps. Today I'm going to be trying to do another easy problem. So let's see how that works. So they're mostly all like, I'm just gonna pick the next easy one. Okay. All right, 703, kth largest element in a stream. Okay. You are part of a university admissions office and need to keep track of the kth highest test score from applicants in real time. This helps to determine cutoff marks for interviews and admissions dramatically as new applicants submit their scores. You are tasked to implement a class which, for a given integer k, maintains a stream of test scores and continually returns the kth highest test score after a new score has been submitted. More specifically, we are looking for the kth highest score in the sorted list of all scores. Okay, so a lot of words there. A lot of, I feel like there's not a lot of, like, important material in that 2,000 page ex or question documentation right here. So we'll have to distill it down to like what is it actually wanting us to do, like what's going on. All of this stuff about a university administration office, all of that's nonsense. We don't need to worry about that. Real-time applicant, okay, that's nonsense as well. This helps to determine cut. Who cares? All of so I think this entire thing here is just like toss it out, get rid of it. Who cares? No one. Okay, you are tasked to implement a class. Okay, so we need to do a class. That's our purpose. And what does this class do? For a given integer, k, okay, so we're going to be given k, and we need to maintain a stream of test scores and continually return the kth highest test score after a new score has been submitted. So, all right, so we first need to initialize this. Okay, so we're given two methods within this class. Now, this add class corresponds to new score. So we're adding a new score. Okay, so when this method is called, what do we need to do? Continually return the kth highest test scores. Okay, so this function will add a new test score and return the kth highest test score. So it says here that it returns an integer though. And if we're looking for like kth highest, wouldn't that be a list of integers? Not integer, right? Like if k is 3, then I would need to return the 3 highest value, or the 3 highest test scores. So it would be like 99%, 98%, and 95%. So it would be 3 numbers in a list, 3 integers in a list. So, but the return type here just says integer, not list of ints. initialize the object with the integer k and the stream of test scores. Okay. Test scores nums. So nums is a list of scores. So I just want to heapify that. So self dot. So I'm creating a member variable inside of this class that I will be able, once I instantiate it here in this init, I can then access it in this add because it's kind of global to this class. So, okay, cool. Self dot, and what do we want to call this? Scores. Okay, so this is the variable equals and then nums. So I'm taking this nums, which is a list of integers, and I'm just capturing it in this scores. Now what I'm going to do is I'm going to do a heapify function. So heap q dot heapify and then self dot scores. Now this heap q heapify, this happens in place, which means that it does the operation on the argument itself. It doesn't return a heapified list. It does it on the list that you pass in. So now once I get to this point, okay, cool. Now when I do self dot scores, this is actually a heapified like list, whereas it's not heapified up here. Okay. So now self dot k equals k. So this one I'm just capturing this k value into a class variable. Okay. So initialize this k largest okay, whatever. So initializes the object with the integer k and the stream of test scores. Okay, I think we did that. Alright, so add. Here we go. Adds a new test score val to the stream and returns the element representing the kth largest element in the pool of test scores. Oh, so we're only returning one value, but it is the kth element. It is like the kth index. Okay. So obviously we can do this with a heap, and that's kind of like we're kind of set up with it because it's in the heap section. But why not a binary search tree? Like if we're always looking for the top element, like the number one largest element, okay, great. Then we do heapify. Or then we can use a heap because we just take it out and it's O of 1. But if we're looking for the k largest, don't I need to iterate all the way through the heap k times, which is no longer O of 1, it's O of k, which k can be any number, so it's not really efficient. Yesterday I went and I was looking at the methods available to me within the heap class. Where is it? Yeah. What's available to me? I'm gonna see if there's one that is like return an index, like the 5th largest or something like that. Okay, heap pop. So I was just thinking about doing like heap pop k times and then just returning that value, but that does not seem like a very efficient way of going about things. So heap push pop. Okay. Actually, let's do this heap push because that's what kind of what we need. So heap q dot heap push. So heap q dot heap push, and then we are trying to take probably 2 arguments, I would guess. The heap goes first and then the item goes second. So heap first, so self dot scores, that's the heap, and then second value is, or second argument is the value that we want to add to the heap. So there we go. So we just added the value to the heap. Good. Again, that operation takes place in place. It's in place operation. So it will modify the self.scores heap list. Okay, so now what? Now what do we want to do? I said we're looking for that method, right? That's what we were up to. We are looking for that method that allows us to be able to get the kth largest element. I'm also realizing, do I need to invert things? Because when I pop, I know that I'm going to get the smallest element. I actually don't want the smallest element, I want the largest element. So I'm thinking maybe I need to do something like up here, I need to take the scores and then negate everything. So what would that be? Like a list. So negative x for, and then nums for x in nums. I think it would be like this, and then we would get rid of this line here. So I would do, what I'm doing here is I'm creating a list, right? That's what I'm doing with these brackets. I'm creating a list. And what is this list? It is going to be this self.scores. So I'm creating self.scores. Self.scores is a list. Now what's in the list? Okay, so we are going to iterate. We're going to do this for loop here. For x, so x is the value that we're getting back each iteration. So for x in what? We always say in and then an iterable, right? Nums is a list, so we can iterate through that list. Now, what's going to happen is each iteration, we are going to get the next value in nums, and that's going to be stored in x. Now, what's going to happen to x is here. You can see I'm using the same x. Okay, so I'm taking x, and I'm just negating it, and then I'm putting it in this list. So the result of that is just scores is going to be the negated version of itself. It's just going to be an inverse negation of itself. And then when I pull the highest, or when I do like heap, if I can speak properly, when I do heap pop, okay, bam, I get the smallest one, but the smallest actually corresponds to the most negative, right? And so that's all I have to do is unnegate it, and that's the largest element. Think about like if you have, I'm going to put in 1,000 and then 1. That's up here in nums. Okay, well I just take 1,000, make it negative 1,000. 1, negative 1. Then on the heap pop, I pop off the lowest element, which one is smaller, a negative 1,000 or negative 1? Well, it's negative 1,000. Okay, so I take negative 1,000 out, and then I just negate it back, and now it's 1,000. Okay, so you got the biggest element that way. Alright, cool. So what are we doing? We are now looking for a method that might be more efficient than heap pop, because I don't want to pop k times. That doesn't, it just, I think it'll work, but it doesn't sit well with me, because it's, if you use a binary search tree, you should be able to at least get log of n, right? or log of k, I guess, in this. Okay, anyways. Heapify. Okay, so in largest, that might returns a list of the in largest elements defined by the iterable. This might be of interest. This might be of interest, but I don't know the time complexity. I wish it. Let's ask. What me about this method and what the time complexity is. Okay. So there's two things that I want to know. Number one is the time complexity. If it is in log of k, where n is the number of elements, k is the iterable. Alright, it looks like that's kind of where we have to go. Anyways, log of n, or O of n log k, which is worse than log of k. Maybe I'm getting my things mixed up. Hold on. Binary search tree would not... No! Okay. A binary search tree would not help me get, like, log of k, because I would need to iterate k times anyways. So, no, never mind. Forget what I was saying about the binary search tree nonsense. Okay, whatever. So, the other thing that I want to do is figure out, like, okay, how do I get, like, there's always a difference between indexed at 0 and number of elements, right? Like, how many elements are in this list? Oh, there's 3 elements. Well, what's the last index? It's 2, right? Because it's 0 indexed. So what I'm trying to figure out is this. I'm trying to figure out how to utilize this in largest method. Does this 3, does that mean 3 elements, or does it mean 3, like, up to the 3rd index, like 0, 1, 2, 3, right? Or 0, 1, 2. And then trying to map that over to what my problem is asking. So yeah, here we see 8, 7, 6. So I guess we take it, I guess, from the 0th, from the 1, from the 2. So I guess that doesn't matter. So we're just going to get 3 elements, okay? And then so now I want to do heap. So my list equals heap q dot in largest, and then I want self dot k, and I also want self dot scores. Okay, so this is going to give me a list of k elements. So I'll have 3 elements if k is 3. Okay, and then I want to return the last one. Return my list indexed at k minus 1. So, like, think about the case where k is, right, like, k is 1 to the length of num plus 1. link +1. Is that a why is it +1, not -1? Oh yeah, that would make sense because yeah, that does make sense. Because in order to index it, I need to put that -1, which is exactly what I did right there. So yeah, it is this k is like how many elements, and then when I do indexing, I just need to -1 of it. But I'm noticing a problem here, which is they actually have a method of in largest. And remember, I said I was doing this nonsense to like invert things to make it when I take the smallest, I actually get the largest, and then I have to invert it. But if there's a method that just gives me the largest, I don't even need to do that. I can just put in the normal nums, I get the heap, and then I take the in largest. So, all right. Should we try it? All right, let's try it. Oof. Okay. Okay. Oh yeah. Obviously. That's why we stored it in the class variable. Here we go. It's loading. This normally means that it's time. Yeah. Mm. Mm. I'm gonna try running it to see if it passes the little test cases. Um, if it passes the little test cases but it doesn't pass this one, then there's no, like, this is kind of like a fundamental problem, that a misunderstanding that I have. So there's not really much point of me just like spinning my wheels doing nothing. I'm just going to take it and say like copy this, put it into GPT, figure out. So now comes kind of the autopsy. So this is how I do my LeetCode is I look at a problem, I do my best to solve it. I try to figure out like, okay, how am I going to do it? I practice, 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 right? I try to understand the logic. But then if I'm number one unable to solve it, or realize that okay, I have a fundamental misunderstanding of something, or there's something I'm missing, okay, go and start doing the autopsy portion of the problem, which is in my opinion the most important portion of solving LeetCode. Is like once you figure out something that you don't know, awesome. That's the point, is to find out what you don't know so that you can improve on it. So we're going to be taking this problem and kind of explaining to GPT like, hey, I was able to do it this way, but I don't think it's efficient. What do you suggest making it more efficient? And then we're able to learn like, oh, that's a much better solution. Okay, cool. And now we put that into our heads. Next time we go to a problem, bam, we get the better solution. So I was able to solve it with an inefficient solution, but there's a better solution out there in the ether, and we need to find it. So let's figure it out. All right, so here is my answer for, and then for my solution seems to work but is time inefficient. Could you help me get a more efficient algorithm? Okay. Let's figure out what it's saying that I should be doing. Okay. So, certainly, The solution you've implemented can be optimized to improve its efficiency. The main issue with your current implementation is that heap queue in largest is called on every add operation, which can be time consuming for this list. To make this more efficient, you can maintain a min heap of size k instead. This allows you to efficiently track the k largest elements with the element of the heap representing the kth largest element overall. Okay, so it sounds like the direction we're going is we have another heap, and how this heap is going to work is before I go and look at how it's implementing it, I'm trying to go over in my head okay, what do I think is happening? And how would I use this new information? So what if I had something like this? I don't know. Self.nums equals nums. Okay, and then I essentially don't even use this self.scores. So I'll keep it there because I don't want to delete it yet. But what if I just don't do that? And instead, I decide that I am going to come here and I want to add scores dot append, because it's a list, value. So I'm appending that to the scores, which is nums, which is the entire list. Now I'm thinking about creating a self dot min heap equals so I want to be able to take off I want a heap that is k elements long. Okay. So what I'm thinking about doing right now is creating a heap that is k elements long, and where I pop from the top, meaning the smallest, and that is the k largest. Trying to go over in my head the logic of this. Okay, so I want so I'm gonna have two variables, or two. I'm gonna have three variables. Self.k, which is the place that whatever about k. It doesn't matter. Self.nums. Self.nums is the full list of the scores. Okay. Now this min heap, I want that. I'm going to add an element. I'm not even going to think about adding elements right now. All I want to do is I want to return the k largest. So why don't I do something like this? That I okay. So in a list of k largest, the k element is actually going to be the smallest, right? So it's going to be somewhere in the middle of this list, of this heap. It's not going to be the largest, it's not going to be the smallest because, okay. Oh, come on, man. Why am I struggling with this one? My coffee is almost out. So, you know what? I think what I'm gonna do is just start randomly writing something and see if I can get some inspiration, because right now what I'm doing is I feel like I'm spinning my wheels. I'm thinking, but I can't organize my thoughts at all. I have no idea like how to even like conceptualize this. Maybe if I like drew it out, but obviously that's not going to be. I'm doing a video right now, so I need to. I can't draw it out. I don't know if. I don't know. So I'm gonna just randomly start writing and see what happens. How does that sound? Okay, so I want to do a min heap. I don't know if that's even the right word for it, but that's fine. It can be whatever it wants. And I'm gonna get the I don't know. Heap q dot heapify, and what do I want to do? Maybe heapify. I want to heapify. Actually, I don't even need nums. I'm just gonna do nums like this, and I'm gonna delete this self.nums because we don't need it anymore, I think. We don't even need the self.score, so that's just adding extra memory that we're trying to keep track of. Self.scores, that doesn't matter. Self.k. Okay, maybe we don't even need that, but that's just one int value, so it's like negligible. These ones are not negligible because this list can be like a million elements long, so we don't want to like carry that long scale. Anyways, so I'm now heapifying nums, and now I want to get the heap q dot in largest self dot k, and then nums, which nums is now a heap. The other thing that I'm thinking about is, okay, so this nums is being passed into this function. Could it cause some kind of like issue? Obviously, this is like a LeetCode question, so it doesn't matter. But like in an actual environment, if I'm given an argument nums and then I do a in-place operation here, I'm actually changing this argument that is passed in, right? It's passed in, and then I'm changing it. So I'm modifying data outside of my own function. So I probably would want to do something like this. So temp list equals nums. Does that like nums.copy or something? Copy something like this, like so that it's not actually modifying this one. Does that make sense? And then okay, something like that. I don't know if that's the correct syntax, but whatever. All right, now we can do this here. So temp list. Okay. And there's k elements in it now. So now when we come to append, what do we want to do? Let's see. So now if the number that we're being given is larger than, so k largest, so if it's larger, I want to add it, right? And then I want to take away the lowest. Or do I need to invert it? I don't know. It's like inverting of inverting and then taking the, oh man, these questions really like bend your mind. Like, in largest k of this element of that index of this. So if what? If what? I don't know. If val is greater than the last element of this heap, maybe? I don't know. I really don't know. So like self dot min heap, can I just index it like at self dot k? Can I -1? Can I do that? If it is, then I want to add it into the this is not going to work. Heap q dot add, was that the function? I don't even know. At this point I'm okay. This is the direction I'm going. We're not making any progress. We're gonna go back here. Okay, so how do they actually do it? So we have the self.init. So we have k, and then we capture this heap here. So, and then nums. Okay, and then we heapify nums, so all of the numbers. So reduce the heap size to k by removing the smallest elements. Okay, that makes sense. So we just do heap pop k times, or not k times. We keep popping until the length of that list is equal to k. So there's k elements in the list. Okay. Then what? Heap push. So yeah, it's not add, it's heap push. Okay. So we add the new value to heap, and then if heap exceeds size of k, remove the smallest element. The root of the heap is the k largest element. Okay, so I'm not seeing why this sentence is correct. If the heap exceeds size k, remove the smallest element. But we just added something to heap, so it's always going to be 1 larger than k, right? What's a situation in which which we add to the heap and we're not getting k? I guess if nums is initially like, I'm thinking nums is initially just nothing, it's an empty list, and then we keep doing the add function, bam, 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 it will be nothing until we reach k elements. Okay. So maybe that's important. I don't think it is. Because we need to return the kth index. So how would that be possible if we don't even have k numbers in the list? And then we come here to this one, and then we return self.heap indexed at 0. But it is not immediately clear to me at all why the 0th index is the kth largest. That doesn't make sense. Why is it that the 0th index is the kth largest element? Okay, let's see. I can't. I don't know why. Let's break down why the 0th index of the min heap represents the kth largest element in your scenario. Min heap basics. A min heap is a complete binary tree where the value of each node is less than or equal to the value of its children. Okay, where each node is less than or equal to the value of its children. So, okay, I think I see. So we pruned off all of the smaller elements up to k, and then the 0th index is always going to be like the lowest number. Okay. Let's just erase all this stuff and see if we can just do it again. So let's just like get rid of that and see if we can just do it again. Okay, so what do we want to do here? So initialize, so we want self.k equals k, and then we want self.scores self.scores is an empty list. No, is nums is equal to nums. Okay, and now I want to heapify that. So heap q dot heapify self dot scores. Okay, now I want to pop off k elements. So while the length of self dot scores is larger than k, heap q dot heap pop, and then self dot scores. Okay, so we're gonna pop off and get the lowest, so we keep pruning lower, lower. Okay, and then now once this score's length is equal to k, that means that the kth element is at the 0th index. Okay, so we're good now. So what I can do is we want to add, so I do heap q dot, what was that, I forget, heap append, heap add, heap push. Okay, heap push, and then self dot what scores, so the heap and then the value. Okay, so now they did like if it's larger than k, then prune. But I think you should always prune, right? Like, well, I'm just gonna try it. Like, what happens if I just prune it? So, heap q dot heap pop self dot scores, and then return self dot scores indexed at 0. So what happens if I just do that, like without their little pruning trick? Oh, great. It's indexed out. Okay, maybe you do need it. If if self dot scores, if the length of self dot scores is greater than k, then do this. Okay, let's see if that works. Wait, why a syntactical error? That doesn't make any sense. Why? Self.k. Self.k. Okay. Let's see. Okay, so it was accepted. Apparently, maybe there's a case where, oh, if initially it's empty, right? And then I add one element to it. I don't want to immediately just pop it. I want to keep that one element in there, and k is equal to 1. So k is equal to 1. Initially everything is empty, but then I add one element to it. If I don't have this like little clause right here, then I'm going to immediately pop it, and then there's going to be no elements, and then I'm going to try to index it at the 0th index. It's going to fail. Okay, so I think that's what the problem was. Whew. All right, so in this video we definitely learned a lot. We got some good practice on heaps, so I'm going to be back pretty soon and doing another video also on heaps. So we're going to keep at it, keep moving forward, keep pushing forward. We're not going to stop. Everyday LeetCoding, and then today I'm going to actually do multiple LeetCode videos. Try to get good at heaps, and then once we get good at heaps, okay, try to go back to depth first search. We've forgotten depth first search a little bit, right? We've spent some time doing heaps. We go back to depth first search, get good at that. Then we go back to heaps and get good at that, and then do another topic. So we're just going to keep hopefully pumping through these topics on LeetCode. So anyways, thank you guys so much for watching this video. If you would like, subscribe to this channel. That would be amazing. I would love that. Anyways, I hope that you guys have an amazing day. And yeah, see you soon. My name is Timothy Lee Grant, and I'll see you hopefully in like an hour. I'm going to get more coffee and relax a little bit, and then back at it again with more LeetCode. All right, see you guys.